What if our auxiliary equation only has one root? What do we do in that case? In order to do that, let's try to solve y double prime minus 4y prime plus 4y equals 0. In that case, the auxiliary equation is r squared minus 4r plus 4 equals 0, which factors out as r minus 2 squared equals 0, and that gives you r equals 2, but which is repeated twice, because it's really r equals 2 or r equals 2. Twice. The only difference is that instead of having ae to the 2t plus be to the 2t, you have to add an extra t. So in fact, the solution y is simply ae to the 2t plus bt e to the 2t. E to the 2. If it was repeated 3 times, you would add an extra t squared, but that would be for higher order equation. And why is that true? Well, let's use a factoring method again to see why. So why? Factoring method. So the first step is to write the differential equation in terms of our differential operators. So y double prime minus 4y prime plus 4y equals 0. That gives you d squared minus 4d plus 4 y equals 0. But I know you want to write this as d minus 2 squared, but instead, let's write it as d minus 2 times d minus 2. Minus 2y equals 0, because we want to employ the same technique. So as usual, you let z be d minus 2y. So this becomes d minus 2z equals 0. So essentially, z prime minus 2z equals 0. So z prime equals 2z. And that tells you that z is ae to the 2t. So far, nothing unusual. But now we want to use the fact that z is d minus 2y. So d minus 2, y equals z. So y prime minus 2y equals z, which was ae to the 2t. And now we want to use integrating factors. So we want to multiply by e to the at. So in this case, e to the minus 2t. So we get e to the minus 2t y prime minus 2 e to the minus 2ty is ae to the 2t times e to the minus 2t. And that is the main difference. Before, on the right-hand side, we had an exponential term, but now actually we have a constant term, because the right side becomes a, and left side, as usual, integrating factor times y, derivative. So in particular, e to the minus 2ty, in order to do that, you integrate a, and the integral of the constant a is at plus b. So you see, this is precisely where this t comes from in, this ae to the 2t plus bte to the 2t. All right, and then all we need to do is to multiply. So y is e to the 2t, at plus b, and then y is at e to the 2t plus b e to the 2t. Which is the same thing we found before, except, I mean, the constants a bit switched, but that's okay.